Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the 10th video, which simply means I'm doing question number 10, whereby I'm only focusing on rates of reaction questions. And please note that, guys, there will be a total number of 11 questions. Um, and all of these questions will have their own video, and most importantly, they are all extracted from past exam question papers. So it's very, very important for you to know how to tackle such questions, because it will give you an edge whenever you write your exams. So please do share the video to your peers so that they may have the same edge as you. And please, guys, do help us grow the channel by just subscribing, liking the video if you're getting any help, and ask questions in the comment section. I'll definitely come back and assist you. Okay, learners use the reaction of magnesium carbonate with excess dilute hydrochloric acid to investigate the relationship between temperature and the rate of a chemical reaction. Okay, the balanced equation for the reaction is given below. Okay, we do have our reactants, which are magnesium carbonate, hydrochloric acid, and for our product we simply have magnesium chloride, carbon dioxide, as well as water. Okay, and then we are told that the results obtained are represented in the graph below. The graph of average rate of production of carbon dioxide in grams per minute versus temperature is given below. Okay, as temperature increases, guys, together we can all see that the rate of production, or rather the rate of formation of our carbon dioxide gas also increases together. So an increase in temperature, by just looking at this curve, an increase in temperature will definitely increase the reaction rate. Okay, now they want us to define the term reaction rate. Reaction rate, guys, you can say it's the change in the quantity of products per unit time, or the change in quantity of reactants per unit time. Yeah? Your quantity can be mass of products, or rather mass of reactants, number of moles of products or number of moles of reactants, or even the concentration of both products and reactants. Ne? But remember that we cannot find the concentration of a solid. So you can either use number of moles or mass. Ne? Yeah, the change in one of the two quantities per unit time. Then now they want us to state two conditions that must be kept constant during this investigation. Firstly, the quantity of my reactants should remain the same. That is, the mass of my magnesium carbonate should never change, as well as the state of division of my magnesium carbonate as well should never change. Ne? And then another thing that should never change, you can simply say the concentration of the hydrochloric acid. It should remain the same. Are you together? But temperature does not have to remain the same. Why? Because in this investigation, we want to know how does temperature affect the reaction rate. Are you together? So we'll keep on changing temperature. Basically, temperature will become our independent variable, and the reaction rate is our dependent variable. Why? Because it depends on the change in temperature. Okay, let's answer the questions. The two conditions that should be kept constant. You can say the mass of calcium of magnesium carbonate, rather, as well as the state of division, or the surface area of magnesium carbonate. And then you can also say the concentration of the hydrochloric acid should remain the same as well. Then now we must use collision theory to explain the relationship shown in the graph. According to the graph, it simply says an increase in temperature increases the reaction rate. Are you together? According to collision theory, it simply say that whenever you increase temperature, the average kinetic energy of particles will increase. Are you together? The average kinetic energy of particles will increase, such that now the average will have an average kinetic energy of particles that will be more greater than the activation energy. Are you together? And if this is the case, we'll end up having effective collisions, or rather, let me say more effective collisions, and hence the reaction rate will increase. Are you together? An increase in temperature will increase the average kinetic energy of particles, and that simply means that our average kinetic energy will be more greater than the activation energy of the reaction, and hence we will have more effective collisions taking place, and that's why our rate of reaction keeps on increasing whenever temperature increases. Okay, and then now they want us to calculate the time taken for the reaction to run. Oh, the learners obtained the graph above using 5 grams of magnesium carbonate with excess hydrochloric acid at 40 degrees. At 40 degrees, they want us to calculate the time taken for the reaction to run completely, or rather to run to completion. Firstly, we must find the number of moles of our magnesium carbonate. Why do I want to find the number of moles? Because I know that the magnesium carbonate is not in excess. That means it is my limiting reagent, so it will be used up completely in this reaction. So the number of moles, it's basically equals to mass all over the relative atomic mass number. Are you together? The mass, that's 5 grams. The relative atomic mass number. Magnesium carbonate, it has magnesium, which has a molar mass of 24. It has carbon with a molar mass of 12, and then oxygen with a molar mass of 16. But I have 3 of my oxygens there. So for me to find the number of moles, I simply say 5 divided by 24 plus 12, and then I have 16 times 3. That will be 5 over 84. So this will basically give me 0.06 moles. So initially I had a total number of 0.06 moles. Are you together? Now they want me to calculate the time taken for the reaction to run to completion. Okay, I'm given the average rate of production of carbon dioxide. Please note that, guys, since this amount will be used up completely, will be used up completely, I know that since the ratio over there is simply 1:1, I know that the number of moles of carbon dioxide that will be formed will be equal to the number of moles of magnesium carbonate that will be used up, because the ratio is 1:1. So I'll simply have 0.06 moles. These are the number of moles of carbon dioxide that will be formed. Are you together? But then I'm given the rate of reaction in grams per minute. So it simply means that all I have to do is to find the mass of my carbon dioxide which was formed. Number of moles is equals to mass all over the relative atomic mass number. The number of moles I have 0.06. The mass, that's what I'm looking for. The relative atomic mass number, I have 12 plus 16 times 2. And then my mass is basically equal to 0.06 multiplied by 12 plus 16 times 2. 0.06 multiplied by 12 plus 16 times 2. And this will give me a mass of 2.24 grams. Are you together? So this is the total mass of carbon dioxide that will be formed at 40 degrees. Are you together? This is the mass of carbon dioxide that will be formed. So my rate of reaction, let me use a different color. The rate of reaction is basically equal to the change in mass all over time. The rate of reaction I was given was 0. At 40 degrees, what is the rate? Let me check. That's 0.5. And then the change in mass, initially, guys, the mass of carbon dioxide was 0 because reactants at the beginning of the reaction were not formed. So it will be 2.24 minus 0 all over the change in time. So therefore the change in time will basically be 2.24 divided by 0.5. And that will give us 4.48 minutes. Are you together? It will be 4.48 minutes. If I want to change this into seconds, I can just multiply the answer by 60, and then I'll simply get my time to be equals to 268.8 seconds. Yeah, so the amount of time, guys, you can simply say that's 268.8 seconds. Okay, 5.4.2, we are being told that the molar gas at 40 degrees, the molar gas volume rather at 40 degrees is basically 1.5 per cubic decimeters. What are you saying? Or calculate the molar gas volume at 40 degrees. If 1.15 cubic decimeters of carbon dioxide is collected in the syringe. Oh, okay. Remember that, guys, the number of moles of any gas is equal to the volume of that gas divided by the molar gas. Are you together? But the number of moles of carbon dioxide that were formed at 40 degrees, we calculated them to be equal to 0.06. Are you together? So that's 0.06 being equals to the volume of my gas that was collected is 1.5 all over the molar volume of a gas. So therefore the molar volume of a gas, that's 1.5 divided by 0.06. 1.5 divided by 0.06. So this will basically give me 25 cubic decimeters. That's the molar gas volume. Okay, and then now we are told that the graph below represents the Maxwell-Boltzmann distribution curve for carbon dioxide at 40 degrees. Are you together? They want us to redraw the above graph in the answer book and clearly label it and clearly label the curve as A. Okay, they just did that for us. And then on the same set of axes, sketch a curve that will be obtained for carbon dioxide at 20 degrees. Okay, at a lower temperature, guys, our Maxwell-Boltzmann distribution curve will have a higher peak. Are you together? And let me draw it like this, because yeah, that's better. There's a higher peak like this. Are you together? And now remember that, guys, I said to you initially, whenever you increase temperature, the average kinetic energy of particle increases, and the opposite is true. If you decrease temperature, the average kinetic energy of particle also decreases. Now, initially, the average kinetic energy was over here at the peak, but at a lower temperature, the average kinetic energy will now be here. Are you together? Okay, and then obviously your activation energy will be somewhere there. to show that the graph with a lower temperature has less particle which will form effective collisions. Are you together? But they did not ask us to indicate your activation energy, so we'll just leave our graph like this. We'll just leave it like this. Né? Just know that the curve that has a lower temperature should have a higher peak. Are you together? A curve with lower temperature should have a higher peak. So that's how, guys, we're supposed to answer that question over there. Né? So just stay tuned and wait for more videos. Thank you.